So we're just going to quickly review what we've looked at so far this term. We're going to start with basically an introduction to functions and relations, okay, types of functions, then we'll look at quadratics and so on and so forth. But we'll start with, first of all, when we're looking at functions, we need to consider what is a range and what is a domain before we go any further. Jeff, what do you think a domain is? What type of values? That'll do. So a set of x values from lowest to highest, which would make the range what, Lachlan? Yep. Now, if we have discrete data, how do we go about that? So discrete means 1, 2, so just data points rather than a function. How would we go about that? Adam. So if we had a set of data that was numerical, say 1, 2, 4, 6, 7, 3, how would we go about identifying the range and domain of that? So you'd identify your x values and your y values and then put them in ascending order? Yep. And your domain would be what then? What would your domain be for those?
Isn't that like just that?
Yep, so what's the x? And what would be your range?
2, 6.
Is it 2, 6 and 3? 2, 3, 6 because we're going from high. Look, cool? Okay, good. Now we use that a bit later on and that rarely comes up, that type. More often than not when we're asking about range and domain, we're asking about the possibilities for a function. Okay, so all functions are relations, but not all relations are functions, as we know. Okay, so an example of a relation that is not a function would be something like a circle. A circle is a relation, but it is not a function. Okay, to test if it is a function or not, we use the vertical line test. Okay, and the vertical line test is essentially saying that we can't have two y values for the same x value. Happy with that? Is that pretty simple? Okay, good. And the last thing we looked at, okay, is discontinuous functions. So functions that break are called discontinuous functions. The point at which it breaks is a point of discontinuity. We looked at examples of discontinuous functions, such as step functions. We looked at tax, okay, and how tax is an example of a step function, or you could look at buying supplies. Can someone please explain to me what is meant by x plus 3, x less than 0, x squared, x greater than or equal to 0? Let's go with Danielle. Oh, so Kemi, you can jump.
When I put x equals x plus 3, x is small.
Yep, so our graph, if I was to draw just a very loose graph here, where would the function be x plus 3? Which side of the green line?
Left.
The left side, so here. And that would look something like this, would it? Who thinks it looked like that? Something like that. Okay, and the gradient of my line there is 1, it should go up to 3. Happy with that? And then what happens after?
Oh, I was going to say when I
So you've dealt with that one, what happens with this one?
when x equals x squared, x is greater than or equals 0.
So what you're saying is when the domain is less than 0, so when the x values are less than 0, we use this function. And when the x values are greater than or equal to 0, we use x squared.
Yeah.
Now, that would look something like this, correct?
Yeah.
Have I missed something? I have. I'll give you. I have.
Like you have to like do the dot.
I have to do a dot. So to show that this graph is including this point at 0, I have to colour that dot in, and to show that it's not including. So if I said when x equals 0, what does y equal? What is fx? You'd need to put that in so you know that x equals 0, or y equals 0 when x equals 0.
Yeah.
Does that make sense?
Yeah.
So we colour in when it's included, we do not colour in when it's not included. Happy with that? Okay, good.